Good morning, class. Good morning, biology, and welcome to our next part of biochemistry. And we're going to dive into how atoms interact with each other and the forces that allow this interaction to happen. We're going to focus mainly on water and salt because they're the easiest. You definitely need to be following along with this in your science notebook and taking detailed notes. There's not a ton to write, but you're going to have to draw with me and figure out how to do these valence electrons and what we call the Lewis dot structure. So get your notebooks out, be ready to follow along. This is going to be some important stuff that I want you guys to know, and here we go. Okay, so first thing we're going to talk about is what these things are called valence electrons and bondings. And so last week we went over how to read a periodic table. So I'm going to jump ahead a little bit actually, just so I can show you guys. And we were looking at something like sodium here. So we found out that this number up top, hopefully you remembered, is the atomic number, and it tells us how many protons and electrons. This is really the only number we're going to worry about today. So hopefully you have a digital copy or a hand copy of the periodic table. I give you guys access to one. There's some in the last slideshow as well. But for today's activity, I'm going to give them all here. But for when you do the one at home, it'll be different. So sodium has the number 11 up here, which means it has how many protons and electrons? So protons should be 11, and electrons should also be 11. And these are going to be the numbers we care about right now. Okay, so just a little review of that. That tells us how many protons and electrons are in the atom. Okay, so in the atom, this one K, for example, is potassium, one of the ones I want you guys to kind of know. The electrons orbit the nucleus of an atom at different energy levels. So what's really going on is these electrons, this is drawn at any similar time, but you're going to have the first two electrons are really close to the nucleus. Well, I mean, not really close, but the closest to the nucleus. And this first energy level can hold 2 electrons. And then if there's more than 2 electrons, the next electrons are going to be held out in this next energy level out here. Okay? And that energy level can actually hold up to 8 electrons. Then we go to the third energy level, and it can hold up to 8 electrons, and so on. So we'll go how that works, and I'll give you guys some rules. Okay. And then valence electrons are going to be our last one. So valence electrons are the electrons in the outermost energy level. So these are going to be the electrons that interact with other atoms. So here's an example of sodium. We're going to go over the rules later, but I'm going to go over them a lot so you guys kind of start to figure it out. The first energy level has 2. Okay, and so since sodium has 2 electrons, there's 11 total, 2 go into this first energy level. Then 8 can go into the next one. So this one's full, and then 8 more go in here. And then there's 1 left over on the outside. So this one on our outside is our valence electron. So sodium has 1 valence electron. Okay. Look at carbon. How many valence electrons does it have? So we look up here. We have 2 in the inner. That's how many can be held in the inner. So this would be full. So our valence electrons are in the outermost shell of that electron, and it can hold up to 8. But how many does this have? 1, 2, 3, 4. So how many valence electrons does carbon have? It has 4. This is why carbon is the backbone of life, because it has 4 spots for different elements to hook up with it. It does all kinds of awesome things. As we're going to talk about these valence electrons, these electrons on the outer edge, valence, these are the ones that interact with other molecules, okay? So to fill up energy levels, they will bond with other atoms. Let's go over our rules for where electrons go. So I want you to write these down. And our first rule is the first energy level can hold up to 2 electrons. Okay, so first energy level can hold 2 electrons, right? So 1, 2 in our first energy level. Okay, the second level can hold up to 8 electrons. So if we look back down at sodium, there is 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the third level can hold up to 8 electrons, and so on and so on. The big thing I want you to get out of this is atoms want their outer energy levels to be full. Sodium here is very pissed off. It only has 1 electron here. It does not want to have 1 electron there. It would rather be at this state where there's 8 nice full electrons. So sodium really wants to give away an electron, okay? Really wants to give away an electron. Because if it gives away an electron or gets rid of an electron, then it has this nice full energy level shell, and sodium is much more comfortable. So sodium is constantly trying to give away 1 electron. Other elements might be wanting to take 1 electron, and so they would bond very well together. Carbon's kind of in a weird place because it's at 4. Right? Do I want to give them all away, or do I want to take some on? So it really has one choice, and that's just to bond with other ones. Okay, we're going to practice drawing these. I want you to draw these with me at home. And we're going to start with sodium. So I already did at the beginning of class. You're going to look for this number first. That's going to tell me how many protons and electrons. So when you draw this, I want you to draw the protons and electrons out for me. Okay, and then we're going to start by drawing our nucleus. We're going to ignore neutrons for this. So I'm going to start with my nucleus here. And I'm just going to say how many protons are inside of it. And I'm going to use a plus to represent protons. And there is 11. Okay, and then I'm going to draw in my energy shield. Sometimes I do these with dotted lines, but that's going to be hard for me to do. And I'm going to label this one first. You guys don't have to do that. You can just count. Okay, so that's my first one. And then I'm going to have my second one here. And then my third one out here. Okay, I'm going to change colors here. You at home probably won't have that option, but okay. So I'm going to look up here, how many electrons do I have? And I have 11. How many electrons can go on my first energy level? And if we look back to our rules, the first energy level can hold 2 electrons. Okay, 2 electrons. So I come into my first energy level. How many electrons can it hold? 2. So I'm going to go ahead and draw my 2 electrons on here. Remember, these are negatively charged. Okay, so one thing I want you to do is keep an inventory of your electrons. So if I just use 2 electrons, how many are left? Now I have 9 electrons, okay? So how many electrons can go in the outer edge? And I'll give you guys a minute to get caught up on drawing your first 2 electrons. And then how many can go on this outer edge? If we look back to our rules again, the second level can hold up to 8 electrons. So I'm going to go up to my inventory. Do I have 8 electrons left with 9? Hopefully we all know 9 is 1 above 8, so I do have 8 electrons to put into this next level. 1, 2, 3, 4. We typically like to bunch them in groups of 2 because that's actually how the atoms work. And it'll make sense when we show them bonding. So I have 4, 5, 6, 7, 8. This is now a full electron level, electron shield. Energy level is full and it is content. And so we've taken 8 now away from our 9. And how many electrons do I have left? 1. And so that is going to be the one that's on the outside. Go ahead and put it up here. This is my valence electron, okay? And sodium has 1 valence electron. And so I'm going to go ahead and write that on here as 2. 1 valence electron. And it wants oh so bad to get rid of that 1 electron. We'll go over what happens there. Okay, so we're going to practice with 2 more of these, and then I'm going to give you guys some to do at home. Chances are you won't even have to draw them because I'm going to teach you a trick, but I want you to draw these 2 with me. They're kind of important. So we are going to do oxygen first, okay? So let's look up here at oxygen. My atomic number is 8, which tells me how many protons? It should all be telling me 8. And how many electrons? Should be telling me 8. Now we want to find out how many valence electrons. I am going to draw oxygen down here. Once again, I'm going to change my pen color. So that you guys can see a contrast. And so I'm going to start with my nucleus, and it's going to have 8 protons. Okay. Then I'm going to have my first energy level. And my second energy level. I can tell by looking at oxygen that since I only have 8 electrons, there's no way I'm getting outside of my second energy level. So I'm going to stop right there with that energy level and not even worry about drawing the other one. In real life, the other ones do exist, and when oxygen's excited, it'll actually push electrons out to those other ones, but that's going to be way later in chemistry and physics that we worry about it. So let's start filling in our electrons. So the first orbital level can hold up to 2. Okay, if you need, you can go back to your rules, right? First energy level can hold up to 2 electrons. I'm going to go ahead and put my 2 electrons in here. Okay, I'm even going to add a little negative to these so we remember that they are negatively charged. Okay, so if I subtract 2 from my first electrons, I now have how many left over? 6. Okay, so I'm going to put in my 1, 2. This time I'm only going to put 1 on this one because you're supposed to actually fill here, bottom and top first, and then you fill the sides with 1 each. Okay, so this oxygen has 6 electrons in the outside, so it has 6 valence electrons, okay? Hydrogen's really easy. Okay, let's draw our hydrogen. Okay, hydrogen is just going to have 1 electron. This is a really easy one to draw. But before we even get there, how many electrons does oxygen want to have? Although I really shouldn't say an element doesn't want or need to have anything. It's just the balance of nature. But easier for us to think about this as humans in human terms of want and desire. So oxygen wants to have 8. So it needs 2 more electrons to be happy. And so hydrogen comes in really well with this. So hydrogen, if I were to draw it, is going to have 1 proton. We oftentimes call this a proton because it just has 1. And then it only has 1 energy level. Okay? And how many electrons does hydrogen have? Well, if it has 1 proton, then it has 1 electron. And so it can have 1 electron in its outer shell. So I'm going to draw 1 electron. Okay, this is hydrogen. This is oxygen. Okay. Hydrogen wants to have a full outer shell. So for hydrogen to have a full outer shell, it either needs to have 0, which is actually kind of what it wants to do, or it wants to have 2. Well, oxygen here wants to grab a couple more electrons. So what happens is these two end up sharing electrons. So hydrogen actually comes down here and shares its electrons with it. Okay, and now the same thing is going to happen on the other side. Okay, 1 proton, and kind of going to draw these actually connecting this time. And then on that one, we get 1 electron from hydrogen. So they are sharing. And what we have now created, if you guys didn't know, is H2O. This is one of the most common elements, most important to life. We have made water. Kind of looks like a little Mickey Mouse head. And water is super important to biology. And I showed you valence electrons to show you why water forms. There's many other things like salt form this way. Pretty much any molecule in the world forms because of some of these interactions. But water is really special because it does this thing called becoming polar. So if we think about these atoms as being charged, if these electrons are over here attached to this negative oxygen, what would the charge be like over here? If you notice, there's a big plus proton here, and there's no negative charges to bounce it out. So water kind of gets a plus charge over here. And the same thing occurs over here, right? So there's no negative atoms on this side of the molecule, so it kind of acts like it's positively charged too. But what's really neat here is now if you count oxygen, we now have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives, but how many positives? So there's 2 more negatives here, which means oxygen is very negative. So oxygen becomes very negative. So water forms something called a polar molecule where we have positives and negatives. And what this comes in kind of handy is if we were to draw water, which we actually know its shape now is this kind of Mickey Mouse shape. So water is oftentimes drawn like this. And it's got a positive, and negatives. And hopefully you all know that negatives and positives attract. So when you get multiple water molecules together, the positive end will come attach to that end.
Don't even lock your doors to keep retrogrades out.
What?
Don't even lock your doors to keep retrogrades.
Yeah, awesome. Just a second, Reeves. And so by doing this, we now get the dipolar nature of water. That'll be enough for your guys' lecture today. You guys have a wonderful, wonderful day, and do your lecture.